Hi, this is just to show you how to deal with some of the time of flight calculations from the TOF mass spectrometer on the AS syllabus. First off, you'll need to know a few equations. First one is kinetic energy, and that's equal to a half times the mass of your particle times its velocity squared. You'll also need to know that mass units are in kilograms, and you'll also need to know that velocity units are meters per second to the minus 1. Also, you'll need to know the equation that the speed or velocity equals distance over time, and distance is in meters and time is in seconds. The other equation that you will need to know is Avogadro's constant, and we all know that Avogadro's constant for 1 mole of particles is 6.02 times 10 to the 23. So, a typical question that you could be given, just knock my lamp there we go. So a typical question that you could be given is this one here. I'm going to take you through it, showing you what I would do with this question. So in this example here, we have an aluminium ion and it's been accelerated to a kinetic energy of 4.52 times 10 to the minus 16 joules. The time of flight that it takes to get from one end to the other is 1.44 times 10 to the minus 5 seconds. And what you have to do is calculate the distance travelled by the ion in meters in the time of flight drift region. Use the Avogadro constant, L equals 6.022 times 10 to the 23 moles to minus 1. Now, the aluminium ion, we know that the mass of a 1 mole of aluminium ions is 27 grams. Doesn't matter if it's plus, 2 plus, 3 plus, it's still 27 grams for 1 mole of aluminium ions. So the first thing you must do is convert the mass of 1 mole of aluminium ions into kilograms. So that's where we would use the mass there. But remember, that is the mass of 1 mole of aluminium ions, and we're trying to find the speed of 1 particle, distance travelled in meters by 1 particle. So what we're going to do first of all is convert the mass of 1 mole of ions into kilograms. So let's just write down what we have. We've been given that the ion is Al27 plus, and we know that the relative atomic mass is equal to 27. The kinetic energy that it's been accelerated to is 4.52 times 10 to the minus 16 joules. So I'm taking all the essentials out of the question and writing them down. And the time of flight, so the time of flight, T, time of flight, is equal to 1.44 times 10 to the minus 5 seconds.